I'm going to work out the practice test for Unit 7. So let's get going. So the first one is to solve by taking square roots. So what I need to do is I need to get everything on one side except for the squared term. The 4 is not involved in the squared term here, so we are going to get the x squared alone. So I'm going to subtract 10 from both sides. That would give me 4x squared is equal to 288. Now I'm going to divide both sides by 4. If I divide both sides by 4, I get x squared is equal to 72. Now I'm going to take the square root of both sides. So take the square root of this side, and that would be plus or minus. As soon as I take the square root, it becomes a plus or minus. So what I'm going to end up with is x is equal to plus or minus the square root of 72. So the next step is to see if that can be simplified. And 72 is equal to 36 times 2. And the square root of 36 is 6. So I get x is equal to plus or minus 6 times the square root of 2. Now let's move over to the next one. So the squared term here is x minus 4. It needs to be alone so I can put it under the square root. So the first thing I'm going to do is subtract this 83 from both sides. So that would give me 9 times x minus 4 squared. And when I subtract 83 from both sides, I get a minus 81 on this side. Now I'm going to divide both sides by 9. And I get x minus 4 squared is equal to negative 9. Now then, I'm going to take the square root of both sides, and of course when I take the square root, I'm going to have to plus or minus, so I take the square root of both sides, and that's going to give me the x minus 4 will pop out from underneath the square root, and on the other side, I have a plus or minus the square root of 9, so the negative will come out as an I, the 9 comes out as a 3, and I'm going to get 3i. Now I'm going to add 4 to both sides, and when I do that, I get x is equal to 4 plus or minus 3i. And remember to write it in standard form, real plus imaginary. So you split the real portion and the imaginary portion up, and the real portion comes first. Notice that when I added the 4 to both sides, it's on the left-hand side of the plus or minus. Okay, the next one says solve by factoring. So, well, first thing we always do is pull out a common factor, so let's see if there is one. There's at least a 2 in there, so let's pull a 2 out. So that'd be 18. And I'm going to figure out what these factors are here, but I'm not going to take the time to run the video up, so hang on. Okay, now when we factor a 2 out, and it's just factoring, I can't get rid of it. But because there's an equal to sign, I could actually divide a 2 out of both sides. So I'm going to do that just to make it simpler. So I'm going to divide 2 out on this side, 2 out on this side, and that's going to give me 8x squared plus 51x plus 18. Remember, you can only do that if there's an equal to sign. Can you divide it out? Otherwise, it has to stay in the entire problem, and it won't affect the answer either way when you do that. Anyway, the numbers that are going to be equal to, so we got AC, that's 8 times 18, that's going to be equal to 144, and the middle term is equal to 51. I need to add to the middle term, multiply to 144. Those numbers are 48 and a 3. So combining those, or taking out the middle term and putting those into replacing the 51x, I'm going to get 8x squared plus 48x plus 3x plus 18 equal to 0. Remember to put your 0 there. Let's be diligent about rewriting the entire equation. So now I'm going to group the left-hand side. That would be 8x times x plus 6 plus 3 times x plus 6 equal to 0. So I have 8x plus 3, x plus 6 equal to 0. So in this one, x is equal to a minus 3/8. And over here, x would be equal to a negative 6, and those would be my solutions. Okay, look at the next one, and it says solve by factoring, so I must factor this. So I'm going to move the 70 over and subtract it from both sides. So I'm going to get 4k squared. If I subtract it, that would be 6 minus 70, that would be minus 64 is equal to 0. And now I'm going to factor a 4 out. So I'm going to get 4 times k squared, and that's going to be 16. So this time I'm going to leave the 4 there, and you're going to see that it's not going to affect the answer. So I've got 4, and this is a difference of squares. That would be k minus 4, k plus 4 equal to 0, and the only thing that's going to make this thing go to 0 are these two factors right here. So that would be k is equal to a 4, k is equal to a minus 4. Next problem, it says use the quadratic formula. Okay, so the first thing I'm going to do is make sure that everything, there's a 0 on the right hand side and everything else is moved to the left. And in this case there is. If I wanted to factor something out, I could. That would make the numbers simpler, but you see that there's nothing that can be factored out, so I'm just going to go ahead and use the quadratic formula. Remember, the quadratic formula is x is equal to a minus b plus or minus the square root of b squared minus 4ac all over 2a. In this case, we would have a is equal to 4, b is equal to a negative 4, and c is equal to 9. So let's go ahead and plug those in. So we have x is equal to a minus b, so that's going to be a minus, and b is a minus 4. So I'm going to go ahead and put it there so I don't mess up the signs. Plus or minus the square root of b squared. So b is a minus 4 squared. So let's write everything out. Minus 4 times a, which is 4, times c, which is 9, all over 2 times a, which would be 2 times 4. Okay, so let's go ahead and simplify this. That's 4 plus or minus the square root of 16. And now we have 9 times 4 is 36. That'd be 9 times 16. That's 144. All over 8. So continuing to simplify, I would have x is equal to, let's try that again. X is equal to 4 plus or minus 16 minus 144, that's a negative 128, all over 8. That would be 4 plus or minus, now negative 128 is 64 times 2, so let's go ahead and write that there. That's going to be equal to 4 plus or minus 8i times the square root of 2 all over 8. Breaking that up into its real and imaginary parts, I would have x is equal to 4/8 plus or minus 8i times the square root of 2 over 8, which then would be simplified into 1/2 plus or minus I times the square root of 2. Okay, the next one, it says use completing the square. So remember, if I had a number in front of b squared, I would have to divide both sides by that number. We can't have a number like 4 in front of the b squared, right? We don't know how to do it that way. So you'd divide everything by 4. But in this case, there isn't one. So I'm going to go ahead and work it, and let's see what we get. So the first thing to do is I'm going to move the 24 to the other side. So I've got v squared minus 10v is equal to 24. And now I'm going to add something to the both sides that would make the left-hand side a perfect square. So it's 1/2 of 10. So that would be a minus 5, and I'm going to square minus 5, and that's going to give me plus 25. Remember, what I add is always going to be positive because it's a square. And so now what I have is I'm going to rewrite the left-hand side as v squared, perfect square. So that would be v, and half the center term would be minus 5 squared, and on the other side I would have 49. Now I'm going to take the square root of both sides, and when I do that, I'm going to have v minus 5 is equal to plus or minus the square root of 49. V minus 5 is equal to plus or minus 7. Moving the v to the other side, I would have, or the 5, adding 5 to both sides, I have 5. V is equal to 5 plus or minus 7. So we actually have to write those two answers out. We cannot leave it like that. That's not simplified enough. So one answer is going to be 5 plus 7. One answer is going to be 5 minus 7. Next question tells us to use the simplify. All right. No, the next one is the discriminant. Okay, now the discriminant, remember the discriminant is just what is under the square root sign, b squared minus 4ac. If that's going to be positive, there are two real solutions. If it's 0, there's one real solution, and if it's negative, there are two complex solutions. So let's go ahead and use the discriminant. If I wanted to, I could divide everything by 2 to get the to make the numbers smaller. I'm not going to do that in this case. So a is a minus 8, b is 8, c is a negative 2. So I'm going to have b squared. That would be a negative 8 squared minus 4 times a times c. So I would have 64 minus, and this would be 16 times 4. So negative 8 times negative 2 is 16 times 4, so minus 64. So what I would end up with is 0. So my discriminant is 0, and that would give me one real solution. Okay, let's use the discriminant on the other one. This one I'm going to have to bring the 3 over to make it equal to 0. And so that would be a minus 4n squared plus 2n minus 3 equal to 0. So a would be equal to a negative 4, b is equal to 2, c is equal to a negative 3. So let's go ahead and use the, the discriminant. B squared, that would be a negative 4 squared minus 4 times a negative 4 times c, which is a negative 3. That's going to give me 16 minus, I'm going to have 12 times 4 is 48. So I'm going to have 16, and since this is a minus times a minus, that's a plus, that's a minus, that would be minus 48. That would give me a negative 32. And since it is a negative number, that would be two complex solutions. Okay, let's go ahead and simplify these. So over here, remember to get rid of the complex number in the denominator, I take it times its complex conjugate. So I'm going to take this thing times the complex conjugate of a negative 4 plus 8i. So that complex conjugate would be a negative 4 minus 8i. Okay, so let's go ahead and multiply this out. We're going to have a negative 2 times a negative 4. That is going to be a positive 8. A negative 2 times a negative 8i. That's going to be a plus 16i. We're going to have 10i times a negative 4. And then we're going to have 10i times a negative 8i. That's going to be a negative 80i squared. On the bottom, we're going to have a negative 4 times a negative 4. That's 16. Then I'll have a negative 4 times a negative 8. That would be plus 32i. 8 times a negative 4i would be a negative 32i. And finally, we got 8 times 8. That would be minus 64i squared. Okay, continuing to simplify, I'm going to have 8. Now this negative 80 over here, this is an I squared back here. That's a negative 1. So that's going to change the sign in front of the 80 to a plus. So that'd be plus 80. That's going to add to the 8 over here. So I'm going to have 88. And I have a 16i minus 40i. That's going to be a negative 24i. And on the bottom, I'm going to have 16. Notice my middle terms are going to drop out. So I'm going to have an I squared. That's going to be negative 1. That's going to change this minus sign to a plus 64. And 64 plus 16 is 80. So I'm just going to have 80 on the bottom. Splitting it up into real and imaginary, I'm going to have 88 all over 80 minus 24i all over 80. Simplifying, I would have, if I divide this by, for the first term by 8, I would have 11 tenths. Plus or minus, and if I divide the next one by 8, that's not a plus or minus, sorry. I would have minus 3i all over 10. Okay, next one. This is just multiplication, so a negative 8 times 7, that's a minus 56. A negative 8 times plus 7i is minus 56i. Then I have a negative 7 times 7, that's 49i. And then lastly, I have a negative 7 times this 7, that would be minus 49i squared. So combining like terms, this this I squared would be a negative 1, so that makes this a plus 49. So I have a negative 56 plus 49. And then a negative 56 minus 49 would be minus 105i. So simplifying again, this would be a negative 7 minus 105i. And what we have is just some subtraction going on. So this is going to be 2i minus 5i. Now this negative distributes in, that would be plus 6. The negative distributes to the I, minus 2i. So I've got 2i minus 5i, that would be a negative 3i. Plus 6 minus 2i. So my i's would combine and I'd get 6 minus 5i. Next one over here, notice that we have a radical in the denominator which we need to simplify. So I'm going to go ahead and simplify a little bit of this at the start. There's no need to have 10/8, so I'm going to go ahead and simplify that by making, you don't have to, but you're going to end up with bigger numbers in the end. So if I divide both by 2, I get 5 times the square root of 8. All over 4 times the square root of 6. Now if I wanted to, I could combine this 8 and 6 under one square root. And I would do that if the 6 would divide evenly into the 8. That would get rid of my denominator. But if I would combine those and have 8, 6, that's really not going to help me a whole lot in simplifying it. So I'm not going to put them under one square root. What I am going to do then is multiply the denominator by the another square root of 6. So I've got 5 times the square root of 8 all over 4 times the square root of 6. And if I multiply both the top and the bottom by the square root of 6, I'm really just multiplying by 1. So that's going to be 5 times the square root of 48 all over 4 times 6. That's going to be equal to 5. Now we need to figure out, can we pull something out of the 48? That would be 16 times 3. So I've got 5, and this would be 16 times 3 all over 24. So continuing to simplify, I've got 5. The 16 would come out as a 4 times the square root of 3 all over 24. The 4 will divide into the 4 6 times, so I could simplify that way, and I should end up with 5 times the square root of 3 all over 6. Okay, this one says write the equation in vertex form. We're going to use completing the square on that. So the first thing I need to do is, now there are two ways to do this. We could either move the 9 over and subtract it from the y and bring it back, or we could just leave it hanging out there. I'm going to go ahead and move it over. Maybe that's a simpler way. So let's try that. So what I'm going to do is I'm going to rewrite this as y minus 9 is equal to x squared. Oh, wait a second. This is a problem I made up, so, and notice what's happened here is I didn't have an x on the 4, so I'm going to go ahead and work this so you guys know how. That should be an x, otherwise we're not going to be able to do it that way. So let's go ahead and work it like that. So what I'm going to end up with is I'll move the 9 over, and I have x squared minus 4x on this side. Now I'm ready just to complete the square. So what I'm going to have to do is add to both sides. I'm going to add some number that is going to make the right-hand side a perfect square, and that is going to be half of this 4 squared. So half of 4 is a negative 2. Negative 2 squared is 4. So I'm going to add 4 to both sides. Y minus 9 plus 4 is equal to x squared minus 4x plus 4. Now let's write the right-hand side as a perfect square and simplify the other. So it's going to be y minus 5 is equal to the x, half the middle number, minus 2 squared. And moving the 5 over now, by adding 5 to both sides, I get y is equal to x minus 2 squared plus 5. So now I'm in vertex form, and my vertex is going to be equal to 2, 5. Okay, write the following equation in standard form. That's going to just be multiplication. So what we're going to do here is we will multiply by FOIL this x plus 4 times x minus 1. So I have y is equal to a negative 1/2. And if I multiply by FOIL, I'm going to have x squared plus 3x minus 4. Multiplying the minus 1/2 in, I get y is equal to a minus 1/2 x squared minus 3/2 x plus 2. Okay, the next one, it's going to be a little bit more complicated with all those fractions, so this is not going to, you do not distribute the 2 in. This is going to be the same thing as saying y is equal to 1/8 times x minus 1 times x minus 1 plus 1/2. So be careful there. And this is going to be y is equal to 1/8 times x squared minus 2x plus 1 plus 1/2. So let's go ahead and distribute that in. Y is equal to 1/8 x squared. If I take the 1/8 times the negative 2 over here, I get minus 1/4 x. Taking the 1/8 times 1, I get plus 1/8 plus 1/2. And finally, to simplify that, I'm going to get y is equal to 1/8 x squared minus 1/4 x. And if I change this 1/2 to 4 over 8, right, so that would give it a common denominator, that would be 4 over 8, I would have plus 5/8. Okay, the next one, it says, for the following occasion, write it in intercept form and state the x-intercepts. Well, I don't know what 17 is doing here. I took this from last year's test and modified it, and I must have, this is just graphing in intercept form. So I'll just quickly remind you that what happens is you'd plot a 3, and then we're not going to work it anymore. The 0 for this side would be 3, the 0 is the -1. So I would plot 3, I'd plot a -1. Halfway in between there would be the axis of symmetry. I'd find the vertex on that, and I could plot it. So that's about all we want to do there. That was last test. Okay, for number 16, it says write the following equation in intercept form. That means we're going to have to factor that. Factoring it is where I get my intercepts. So I'd have y, and this is an AC middle problem, so AC is equal to 3 times a -2 is a -6. The middle is equal to a -1. So the numbers I'm going to be looking for are add together to be a -1 multiplied a -6. That would be a -3 and a +2. So what I could do is rewrite this as y is equal to 3x squared minus 3x plus 2x minus 2. Y is equal to 3x times x minus 1 plus 2 times x minus 1, and let's check that last term. 2 times x is 2x minus 2, so that's correct. And so I'd have y is equal to 3x plus 2 and x minus 1, and the intercepts of this would be x is equal to a -2/3, x is equal to 1. In point form, that would be a -2/3, 0, 1, 0. Okay, this says graph the following quadratic inequality, and these are in standard form. So, okay, I didn't want to take up a lot of time graphing this because I knew that we already knew how to graph it. So anyway, what you're going to do is this is standard form. So you find the axis of symmetry of the minus b over 2a. So b is a minus b over 2a, and b is 6. So if you work that out, you get the axis of symmetry as x equal to 3. I put that on the graph. And then I needed to find the vertex, which is on the axis of symmetry, so I plugged 3 into this equation, and when I did that, I got 2 for the y value. So my vertex is 3 over 2 up, so I put that on the graph. Then I needed 2 more points. So I've substituted 0 in for x to get the y-intercept, and it's at a -7. So 0, -7 is one of my points, and there would be a mirror point 3 over on the other side, so there's my other mirror point. And so I was able to draw the parabola, which would be a dashed line because this is a less than. It does not have an equal to sign underneath it. Then I tested the point 0, 0 to see if I should shade outside or inside the parabola. So when I tested 0, 0, I got 0 is less than a -7. Well, that's not true, so the point 0, 0 is not a solution. We'd have to shade the inside. Okay, the next one, since we know how to plot quadratics, I went ahead and just plotted it to take up less video time. And you can see that what we have is we have no equal to sign, so both of these are dashed. They're both shaded on the inside, and the overlap of the shading is this little blue region. So if you wanted to, you could work it out, but that's what you're going to get as an answer. Okay, the next problem says solve the inequality algebraically. So we're going to have to figure out where this crosses the x-axis, including the shading, but we're not going to draw a graph. So the first thing you're going to do is try to figure out where this crosses the x-axis by finding the solutions or the x-intercepts. And sometimes we'll be able to factor it, sometimes we won't, and we'll have to use the quadratic formula to find out where the solutions or where it crosses the x-axis, where those values are going to be. We have to make sure that we have a 0 on one side and everything else on the other. Then the next step is to think of this as like it's an equal to sign for right now. So we're going to rewrite this as x squared And minus 11x plus 28 is equal to 0. And we're going to factor that. In this case, we can factor it. Otherwise, I'd have to use the quadratic formula. So we would get two numbers that add to negative 11 and multiply to 28. That's going to be x minus 7 and x minus 4 is equal to 0. So my values where this is going to cross the x-axis, and let's just draw a little number line out here so we can kind of visualize what's going on, is this is going to cross the x-axis at x equal to 7 and x equal to 4. Now those are going to be open dots because there's no equal to sign here, so I'm going to have a value here at x equal to 4 and x equal to 7. And you can see that this is going to divide my number line into three parts. This is the x-axis. And right here is x equal to 4. Here's x equal to 7. And we're going to have these areas. We're going to have this place out here is where x is less than 4. Out here it's going to be x is greater than 7. And in the middle here we're going to have where x is between. So let's go ahead. Now we're going to test points. It's broken this into three intervals. So let's go ahead, and I'm going to make a little chart, but I'm going to stop the video for that. Okay, so I went ahead and broke this thing up into its intervals. I have the x is less than 4. I'm going to test a point to the left of that, 0. And when I test that value, I plug it into this equation. I got 28 as a value, and then I have to ask, is 28 less than 0? Does it make this equation true? No, it does not. When I test a point between 4 and 7, that would be in here for the middle part of this, I tested the point 5, put x equal to 5 into this equation. When I do that, I got the value of a negative 2. So is a negative 2 less than 0? Yes, it is. And then I tested the other interval, which was x greater than 7, and so I picked a point of 8 out here, and I plugged it into the equation here. So I plugged 8 in, and I got 4 as a value. 4 is less than 0. Not true. So yes is actually the one that I'm looking for. So the solution to this would be 4 is less than x is less than 7. So 4 is less than x is less than 7. And that would correspond to this piece in here. So you could kind of envision a parabola crossing with the shading on the inside. Okay, we're moving on to the next question. Now this is a word problem, and there's a couple corrections kind of here. So the first thing is that we can't have an x and a t both in the same. So this x squared here should be a t squared. And if you wanted to, you can consider that y is h. It's the height. So I'm going to leave it as y, but it's the height. So let's go back and talk about the original equation that we had from when dealing with dropped objects. The height of an object after a certain amount of time, t, is equal to a minus 16t squared, where the effect of gravity is the minus 16t squared, plus v0 times t, where v0 is the initial velocity, upward. So this would be the term that equates to something being thrown up in the air. If it's dropped, this term would be 0 because the initial velocity is 0, plus h0, where h0 is the starting height. Okay, so it's the question 21, what is the initial upward velocity? Well, that would be the term in the center here, and the initial upward velocity would be 32 feet per second. What is the height of the basketball when it's released? Well, that would be the initial height at time t equal to 0. So if I put a 0 in for t, I just get 2 left, which is the y-intercept. And in the equation, you could see that h0 over here is the same as 2, so the thing would be released at 2 foot high. Now, the next part of this is kind of complicated, so I already worked it out. And okay, for number 21, the initial upward velocity is going to be the center term. In this case, it's going to be 32 feet per second. And if I put zeros in for the, and this, I think I already mentioned, this should be a t squared. If I put 0 in for our t, that would leave me with 2, so the initial height is 2. For the next part, it says find the maximum height of the basketball. That's going to occur at the vertex. So what I need to do is find where the vertex is on this. So I'm going to use x is equal to a minus b over 2a because it's standard form. So plugging in my numbers of a minus b, that would be a negative 32 over 2 times a, which would also be a negative 32. I get the vertex occurs when it's 1 second on its path. So 1 second out is where the vertex occurs. To figure out the height, I will plug 1 second into the original equation. So plugging 1 into the equation here, I would get a value of 18. So at 1 second, the ball reaches a maximum height of 18, which is the vertex. Okay, moving on to this problem number 24. It says how high, or what's the time when the basketball is 7 foot above the ground and it's caught. So what I'm going to do there is I need to find the solutions for when y is equal to 7. So I plug 7 in for y, and then we never solve any quadratic unless it's equal to 0, so we move the 7 to the other side. That would be a negative 5 over here. And now I solve it using the quadratic formula. So if I plug all these numbers into the quadratic formula, you can see that I solved it over here. What I get is I get two values. I get a value of 0.19 seconds, and I get a value of 0.18 seconds. So actually there's two values when the ball is 7 foot above the ground. One of them corresponds to when the ball is on its upward trajectory and hits 7 feet, and the other one is when a person on the other side catches it when it's 7 foot tall coming down, or 7 foot high coming down. On the way up, that occurs at 0.2 seconds, and I'm not interested in that. I'm interested in where it's coming down and caught. That was the second solution. That would be 1.8 seconds. The next 25 through 27 is graphing complex numbers. So remember that when I graph a complex number, I use the complex number plane. That means any movement in the y direction is the imaginary part. Any movement in the real direction, that's the x-axis. They would go over here on the x-axis. So for 3i, what that is, that's really 0 plus 3i, so the real portion is 0. So I don't make any movement left or right, and I just have a movement of upward of 3 in the imaginary portion. So that point would be up here. For number 26, that's the same thing as negative 2 plus 0i. So I have a movement of a negative 2 in the real direction, but no movement in the imaginary. And the last one is a negative 2 minus 4i. That would be a movement of a negative 2 in the real direction and down 4 in the imaginary, putting the point right there. Okay, the last group of questions says compute the power for the imaginary number. And what we're going to do here is the big thing is an I squared is equal to a negative 1. And I will break all these problems up in so that I have a bunch of I squareds multiplied together. So for example, I3, that could be thought of as I times I squared. But I squared is a negative 1. So that would be I times a negative 1. Well, that would be a negative I. I to the fourth. That's I squared times I squared. I squared is a negative 1. Negative 1 times a negative 1 is equal to 1. I to the fifth. That's equal to I squared times I. So I would have negative 1 times a negative 1 times I would be positive I, because a negative times a negative is a positive. I to the sixth. I squared times I squared times I squared would give me I to the sixth. Negative 1 times negative 1 times negative 1 would be a negative 1. I to the seventh. I squared times I squared times I squared times I. That would be I to the seventh. Negative 1 times negative 1 times negative 1, corresponding to the I squareds, there's 3 of them, times I would be a negative I. And lastly, I have I to the fourth, or I to the eighth. That would be 4 I squareds multiplied together. So negative 1 times negative 1 times negative 1 times negative 1, that would give me 1. Okay, and there's one mistake back here. I'm going to go ahead and correct it. It is the discriminant one. This one right here. Let's rework that. So the discriminant is b squared minus 4ac Okay, so in this case, b squared, that's 2 squared, not the negative 4 squared. So I've got 2 squared minus 4 times a negative 4 times c, which is 3. So I have 4 Let's try that again. Okay, so so the first thing you need to move the 3 over. So that's going to be a negative 4n squared plus 2n minus 3 equal to 0, because you need to get it in standard form. So I already had a, b, and c written up here, so that would be b squared. That's going to be 2 squared minus 4 times a times c, and c is not 3. C is a negative 3. It's hard to see up there. So negative 3. So I've got 4 minus 48. That would be equal to a negative 44. So actually the value of the discriminant is a negative 44, and it would still be two complex solutions because it's a negative number.